Hey everyone, welcome back to the channel. Today we have a 6L80E on the bench. We're going to tear it down, inspect it, see what's going on inside of it. Story with this thing is it came in as part of another transmission build, kind of a core deal, where I gave a little bit of credit for it. So I'm not exactly sure what's specifically wrong with this thing. It did fail. I mean, it's not like a good use transmission or anything like that. The customer gave me like kind of a vague description of what the deal was with it, but to be honest, it was so long ago I can't remember. So I'll find out as you find out. So we'll kind of get into it and explore it together. So 6L80E transmissions came into being in 2006 in select cars, trucks, SUVs, and then they began to proliferate across all of the GM medium and heavy duty lines in the subsequent years. Through end of production in 2020, where they were superseded in the later years by the 8-speed and 10-speed transmissions. So there's a lot going on with these things in terms of all the different pattern failures and numerous updates that GM made throughout the years, and there's a lot of detail you need to know when it comes to what updates need to happen, as well as what the common failures and associated causes are inside the transmission, because there's a whole boatload of them. So we'll go through all of that in detail with this teardown, so that you have all that information and knowledge you can apply to your project, or if you're just watching this to get a better understanding of the 6L80E for the purposes of maybe having a more intelligent conversation with your transmission builder or shop, or just wanting to know what your options are if you're having problems with yours. This will be a good video for you, because it'll give you that contextual detail to kind of approach that situation. So I like to tear these down in a certain way, and I think most builders follow the same pattern. What I'll do is I'll take the pan off, and in this case there's supposed to be 18 10mm bolts, but I only see 4 or 5, so I guess it'll make it easier, but that's kind of the nature of cores sometimes. But anyway, we'll take the pan off, pull the filter off, set it aside, and then what we'll do is put the pan back on, and then we'll take the bell housing / pump assembly out, take the extension housing off, and then we can start going through the rest of the transmission. So you'll see me use a variety of specialized tooling, and I have a separate video on that kind of breaks down all the different special tools you'll need to work on these units, teardown, inspection, reassembly, all that good stuff. But suffice to say, there's some that are straight up mandatory. In other words, you just need to have them, with you to work on these. They're not difficult transmissions to handle and to, take apart and put back together, at least relative to some other units, other types of transmissions, like 4L80Es, for example, to me are a lot more tedious and, a lot more finicky. But you do need some specialized tooling for the 6L80, and it's kind of more tool intensive than most transmissions, at least predecessor units. So anyway, let's go ahead and get started. I'll reposition the camera so we have a better view of what's going on, and we'll begin. Okay, as with most transmissions where end play is important, which is pretty much all of them, you want to take your input shaft. First, what I like to do is I like to spin the input shaft, and then I'll also spin the output shaft. If the input shaft and the output shaft don't spin freely, once you mechanically take the transmission out of park, then you should suspect that there's something, wrong hard part wise inside the case. Something broke, maybe front or rear planet, or one or more of the hubs, something like that. Both of these shafts spin freely. I mean, that's the first thing I checked when the core came in. A great many of 6L80E transmissions come into the shop because the converter failed. The JMBX converters, that's the production, I guess, identifier code, if you will. For example, 4L60Es use TMBX, 6L80Es use JMBX. And the converter itself was under-engineered. The converter clutch is only 20,000th of an inch thick, and that's one of the reasons they fail. But when you're tearing down and inspecting a unit, when you know the converter's failed, you really want to pay attention to several things and inspect and or test several different areas inside these transmissions, starting with the torque converter seal right here. So you want to take this seal off. I mean, I just cut it, but what you want to see is if this seal is rolled over, flattened, hardened, or otherwise damaged. Let's say it looked like this upon taking it off. This seal is, kind of on the hard side, though that could be because it was sitting out in the elements for a while, who knows. But If this seal is flattened and or it's allowing fluid to bypass it, then that is going to cause the converter clutch to slip. And because the converter clutch is applied in multiple different gears, not just overdrive like the legacy 4-speeds, then that will lead to rapid failure because that combined with the under-engineered design to begin with, it's pretty much assured that it's going to have a shortened lifespan. So you want to check that. The other thing you want to do is pull in and out on the input shaft. With the 6L8090s, GM did not offer selective thrust washers or any other means to adjust end play. It's more or less fixed. However, when you go to overhaul the transmission, more than likely you're going to have to machine the pump. So you machine the pump body / bell, and you also machine the pump cover. And you're going to probably take anywhere from 15 to 20 thousandths of an inch off in the aggregate. And so that's going to change the relationship between your 3.5R clutch drum and the back of that thrust washer, and otherwise increase the end play to a point where it's dangerously high. So in other words, way too much. Sonex makes a 20 thousandths thick thicker than stock thrust washer. You'll want to install those anytime you machine the pump. And I'll get into much more detail when we go through the subassembly portion, but let's go ahead and take the pan off, and then we'll get into the rest of it. So as I was saying, 18 10mm bolts, that's what should be on this thing. But looks like we only had 2. Alright, carefully inspect the pan. You see a lot of fine material in here. This is typical of what you see when the converter clutch fails. You have a whole bunch of material here on the magnet. So again, this is going to be one of those example situations where you have to go through kind of a methodical, stepwise testing, inspection, evaluation procedure to figure out why that converter failed. Was it just simply due to the under-engineered design of the converter itself, or were there other factors that contributed it to its failure, so that when you go back with it, it doesn't happen again? All right. These gaskets are technically reusable. I would still purchase a new one. I mean, who knows how long it's been in here. All right, we're gonna go ahead and put the pan back on. This thing had no filter anyway, so I guess I didn't need to do that. But in a normal situation, that's how I would do it, because the the filter gets put into the pump. It goes into the pickup area. Of course, I didn't know that, so all right. Selector shaft nut takes a 15mm socket. And then one other thing I'll mention here, this is going to be the location for your cooler bypass valve. This is the cause of a lot of issues and failures with these units. Particularly, they will fail and cause the transmission to overheat, and that will stress all your clutch packs, but in particular, the 4, 5, 6 clutch is especially vulnerable. All right, let me take the extension housing off first. And these, I recommend you use a 1/2-inch drive impact, and same with the bell bolts. I think these get something like 40 foot-pounds, and then the bell housing is held on via 53 foot-pounds of torque. So 15mm on these, as well as the bell bolts. duct down. These bottom ones could be a little tricky just because there's almost no room to work for your socket. Okay, it's obviously a 4x4 unit. The two-wheel drive extension housing is also fairly short and stubby. So, as you can see here, every once in a while I will see this. This tells me that either it was just contaminated, you know, due to exposure in the elements, maybe it was sitting outside somewhere for a long time, or there was, you know, something going on, some contamination in the fluid where maybe coolant and fluid were mixing. If that's the case, which it doesn't look obvious just based on the color of the fluid by itself, but if that's the case, then you're going to need to replace your pump assembly and valve body. And you're probably going to need to replace a lot of other things too. When coolant is introduced into the system under high pressure, it displaces the lighter transmission fluid, and you have metal-metal contact, and you have no lubrication. So, excuse me, no lubrication. All right, let's go ahead and yank the pump off. I'm going to set the pump aside for now, and then later on we'll go through it in a lot more detail. So like I said, 53 foot-pounds. So most of your 3/8 inch battery impacts are probably not going to pull these bolts off, at least not real easily. There is a snap ring in this groove here, so before you go to punch the seal out, just make sure you take off that snap ring. Pump can be kind of cumbersome, so just kind of be aware of that. And the other thing I'll mention is that these transmissions are rear heavy, so if you're maneuvering it around or whatever, just expect to know that I would say about 70% of the weight is actually in the rear. All right, I'm going to put the whole pump assembly aside for now. We'll get into it later, and I'll talk about all the problems that you need to investigate and check for that are related to the pump. All right, now what I'm going to do is I'm going to turn it back around, take the pan off for the final time, and then we'll take off the valve body, control body complex. So that's your Techum, your internal mode switch, the upper and lower valve body, and spacer plate assembly. Get this out of the way. Okay, so in, I believe, mid-2007, and I'll annotate the video if this is not correct, but in mid-2007, GM changed the bolts that hold the whole valve body assembly onto the transmission case to inverted Torx plus 50. I call them starfish bolts, so if you hear me referring to starfish bolts, that's what I'm talking about. And they require a special socket to remove. So the socket is a snap-on 10 EPL. I think it's at the focus. Okay, 10 EPL, and that's what you want to remove these bolts. I believe an E12 socket will also work, inverted Torx E12. So disengage the case connector lock first, and then we can go ahead and start removing the starfish bolts. 6 of them in total. And then the whole assembly will come loose. Alright, so that's basically it. I'll point this out now. So you have a QR code, and then you have what's called a Tecum, I guess, serial ID number. The serial ID here is 242-56124. If you need to replace the Tecum itself, the transmission control module, you need to acquire a Tecum with that same ID, because what that does is it really denotes the operating system, the specific operating system that was installed onto the vehicle to control the transmission. If you install a Tecum that is not, the same number, or doesn't have the same number, then you more than likely will have a lot of problems controlling the transmission. I mean, it'll shift weird. It will, probably shift hard, or, maybe even not shift at all. I mean, I've never actually installed a Tecum incorrectly, or, wrong Tecum onto a particular transmission, so I have no idea, first-hand experience-wise, what happens, but everything in the literature and, also in discussion forums indicates that the transmission simply will not work correctly and may, end up getting damaged. I'll do a separate video on the teardown and inspection and testing of the valve body assembly, because there is a multitude of drivability issues and problems and failures that have their cause inside the valve body. All right, so you have your seals. And then on the back of the valve body, there's additional seals as well for your clutch feed circuits for the 1, 2, 3, 4, the 3.5R and the 4.5.6. Those seals seal off the 2.6 clutch and the low reverse clutch. All right. So this is the 3.5R drum right here. This is going to be your 4.5.6 clutch drum and front planet. And then this is your 4.5.6 clutch hub. I'm going to just keep them together. Like I said, we'll go through them in much more detail. So, don't worry if, you think you're missing something. Trust me, you're not. Okay, here's your 1, 2, 3, 4 hub. Here's your bearing. This is your 3.5R clutch hub. And just based on what I'm seeing so far, it's clearly obvious the transmission overheated. More than likely that cooler bypass valve failed. The converter looks like it also failed. So, kind of the story, same story with these things. All right, your case pass-through connector. It takes a lip seal and 2 O-rings. So you'll replace that on overhaul. It's got a little engagement tab there on the front. That's what you line up with the connector on the valve body. Okay, something very important. When it comes to the parking assembly and parking rod specifically, it is critically important that you replace this parking rod on all overhauls if you're working on a 2017 model year unit or earlier. Reason being is that the parking rod here at the end, where the rivet, you know, kind of binds the bullet, if you will, or the actuator for the parking pole to the rod, you know, basically making it an assembly, likes to fail. It'll mushroom out, and then when it fails, the little bullet, which you'll see in a little bit, will actually be independent of the rod, and then you'll lose the ability to put the vehicle in park. So, I mean, if that happens, then obviously, you know, you're going to have a world of problems unless you're really, really quick with wheel chocks or something, and or you got a really, really stout e-brake. So, GM updated the part number. The root cause of this problem is the lack of hardness or incorrect hardness for that rivet. And GM finally got the hardness correct in 2018, though they made several changes to it over the years. All right, so you're going to need a roll pin punch. You want to disconnect the rooster comb from the selector shaft. You're going to punch out that roll pin, and then we're going to use a special tool to pull the other two roll pins out that secure the parking pole housing and the selector shaft itself. All right, let me see if I can get this at an angle to see what's going on. All right, so just use a regular roll pin punch, nothing fancy. Get a little bit better angle here. You know, once you got it kind of mostly out, you just got to change up your angle a little bit and then pound it out the rest of the way. You can replace these roll pins. I generally do. I mean, they made a couple of changes to this roll pin over the years as well. I believe the length was increased to, or I should say by 5 millimeters or so. And I'll have to annotate the video with the specific year they did that. Alright, so there's that roll pin. Alright, next we got to use that special tool. Tool in question is going to be Kent Moore DT 48550. Basically, it has a collet style end to grab and hold on to the roll pin, and then you just wrap it out with the slide hammer end. So a 5/8 and 7/8 inch wrench will be needed to tighten down the collet. So you want to get it on there as tight as you can. And then just, you know, wrap it out. And sometimes it's going to take a few goes at it, a few tries. Some of these are in there really, really tight. So and then what I'll do is I'll loosen it a little bit as it's coming out and cinch it down further so that it doesn't come off again. So it's actually lefty tighty, righty loosey on the 7/8 inch 7/8 inch nut surface. Change the camera angle a little bit so you can actually see it coming out. And by the way, this is my least favorite part of this whole job. So they're really in there, and that's a good thing, right? You don't want them coming out. But it does take a while to get them to, you know, fully come out of the case. So just be prepared for that, and you will not be getting these things out without this special tool. All right, now we're gonna pull the roll pin for the selector shaft. So round 2. Alright, again, get it as tight as you possibly can. Otherwise the roll pin's not going to come out. And you're not going to damage the roll pin, but I guess if you do, then you could always replace it. Okay, I'm sure you figured out by now, the selector shaft roll pin is easier to deal with. So here they are. This is going to be your rooster comb to selector shaft roll pin. Notice it has the little setback. This is going to be your parking pole housing roll pin, and then this is going to be your selector shaft retainer pin. And then you may have to tap out the selector shaft itself. A lot of times it will get bound up on the inner bore of the rooster comb, but just make note how it goes. And then your selector seal. All right. Like I said, if you are working on a 2018 model year unit or later, you can just simply inspect the rivet here on the end of the rod, make sure it's in good shape. It should be, but because we're working on a 2011, you don't have to waste your time. You just replace it with the updated part, and that's it. I want to say they're 30 bucks, 35 bucks, genuine GM. So, all right. Now we're going to attack the center support snap ring so we can get the rest of the guts out of the transmission and start going through the sub-assemblies. So let me zoom in just a little bit. Okay, you got two ends of the snap ring. Just make sure you note where they are. Okay? Sorry about that. Because you want the snap ring ideally to go back in that same spot, or generally speaking, in roughly that same arrangement. So most of these will be arranged such that the two ends are on the 9 o'clock position relative to the the bottom of the case. So if this is 12 o'clock, this is 6 o'clock, here's 3 o'clock, here's 9 o'clock. Most of the time they're clocked in the neighborhood of 9 o'clock to about 10 o'clock, 11 o'clock. So as long as you're somewhere in there when you go back with it, and there's no interference, the wide end of the snap ring is aligned with the little cutout in the case, then you should be fine. Now, to wrangle this thing, you're going to need some giant snap ring pliers. There's really no way of getting around it. It's too thick. It's under too much tension. I mean, you could try, but I would strongly advise against it for combination of risk and safety. I mean, you risk damaging the case maybe, or you risk hurting yourself if the thing flies out at you. All right, so the camera's kind of right in the way, but let me see if I can get it. Grab it. Gat it. I want to gat it. If I can get at it and grab. All right, so just make sure you're fully engaged. Which is kind of a problem for me right now. Yeah, I'm gonna have to move the camera a little bit. And then go at it. So this is exactly how it was oriented in the bore. You have the oval side here. It was clocked roughly at the 8 o'clock position, and then the small circular engagement hole was at roughly the 10 o'clock position. All right, so the last items in the case are the gear train and the center support. Center support is in here. Can be a very tight fit coming out. And I already see that I've clocked it. Got it sideways. So this is going to be your 2/6 clutch. And this is going to be in here your low reverse clutch. And then in here is going to be your low one-way sprag clutch. So again, we'll go over all particulars once we start tearing through the sub-assemblies. Lastly, you have your gear train and your bearing. All right, so this planetary assembly is what's called a Raveno style planetary carrier group. It's got an integral upper and lower gear set. So you got your ring gear, your planetary, and your sun gears, you know, more or less stacked double-decker style. Then you have your case bearing. Case bearing goes like this. And then here's the planetary carrier group. Like I said, we'll get into that in more detail in a little bit. Okay, so you have your rear case seal and your rear case bushing. Obviously, you'd replace those on overhaul. Other than that, the case is more or less empty. All right, we'll get the case off the bench, I'll reposition the camera, then we'll start going through the sub-assemblies where I'll discuss all the drivability symptoms, patterns, and related causes as we go through each part. Okay, got the bench cleaned off, so we can now dig into all the sub-assemblies, and here I'm going to be a lot more deliberate and talk through all the different changes, updates that were made to these transmissions as a result of common pattern failures and issues, you know, as they kind of matured over their life cycle. So between 2007 and 2012 is where a preponderance of the changes were made. Overwhelming majority of changes, I would say 90 to maybe even 95% of all of the updates GM made to these units took place in that range of years. So we'll start with the pump. These are all 8mm bolts, including the stator to pump cover. So remember at the beginning I talked about converter failure and, you know, how to evaluate and kind of, you know, investigate for root cause behind why the converter failed in your particular unit that you're working on. One of the things you want to look at is this rear bushing here in the stator. This is true really all transmissions that are similar to this, where there's a you know, bushing in the rear of the stator. This bushing likes to wear out, and when it does, it will cause a whole bunch of issues. You know, sometimes DTCs will set, you know, in other words, trouble codes. Sometimes they won't. But if this bushing is excessively worn, then it will likely cause converter failure, you know, premature failure burnup, you know, while vehicle's in operation. So I'll show you how to check this once we have the 456 assembly / input shaft all apart. Because you want to make sure that when you go back with these units, your bushing clearance between the bushing and the journal on the base of the input shaft is no greater than 0.02 of an inch. More than likely this is a lot greater, so that by itself could potentially explain what happened, but again, we'll check, we'll verify, and, you know, go from there. So in 2009, GM changed the design of the stator sealing rings. As you can see here, we have locking tabs. Let me zoom in. Okay, you got locking tabs here, and underneath these sealing rings, you have support O-rings. What the problem was is that in the earlier units, there would be a lot of reports of slipping in reverse, third, and fifth gear, as well as on takeoff if, you know, the sealing integrity was particularly compromised, because the sealing rings of the first design would not adequately seal against the bore in the 3.5R clutch drum. Okay, so I'm gonna just drop the drum. Let me zoom out. So what the support over underneath these sealing rings do is they provide outward pressure so that the rings seal firmly against the drum. So we'll kind of take one off. And we'll zoom back in. And you can see the support O-ring underneath. So earlier units do not have this. However, the pump cover never changed throughout the entirety of production between 2007 and 2019. So in other words, The aluminum part here, that's the pump cover with all the valving. That never changed. So you can retro back the entire assembly, this half of the, the stator pump cover portion of the pump, onto an earlier unit, and by virtue of doing that, you've just solved that particular problem. Okay. Let's see if I can get one of these off real quick. They can be a little tricky. Okay, these will come in the overhaul kits, so obviously you would never reuse pre-existing stuff, but that's what should be installed. Now, don't try to install these on an earlier designed stator. If you do, you're going to have all kind of problems getting the 3.5R drum on, and eventually something's going to fail. So you absolutely do not want to do that. So they just interlock, just like this, and then you just take them off however you want. Now, there is an updated sealing ring kit for the earlier models that did not have this design that seals a little bit better. So if you have an earlier model you're working on and you don't want to retro back one of these stator pump cover assemblies, maybe you don't have one, or whatever, you don't want to do it, then you can purchase that updated sealing ring kit, and that's what you would want to do on every overhaul of a pre-2009 unit, or any unit that has the first design stator. And that old saying where you talk about walking and chewing gum at the same time? It's not something I'm particularly good at. Okay, so while I'm at it, another thing you want to be mindful of is the gasket that sits between the stator and the pump cover. Now, GM will tell you not to touch this, not to replace it unless it's damaged. Well, the catch-22 here is well, you don't know if it's truly damaged unless you look at it. Now, if you had issues with either cross leaks, to where you have like tie-ups or bind-ups, or slipping, and it was kind of, hard to pin down, or you had really kind of bumpy, jerky type shifts, and you've tested your compensator feed regulator valve bore and that was deemed to be healthy, then it's possible that the gasket is excessively worn at the compensator feed circuit location and or the feed ports, locations for the 1, 2, 3, 4 or 3.5R clutch drum. So it's recommended that you replace this gasket on all overhauls, 8mm bolts, and then you just press the stator off the pump cover, and then you can simply inspect and replace the gasket. Now, these bolts have a tightening sequence. So when you go back with it, you need to follow that sequence. It's in the ATSG manual. It's not terribly difficult, but you just want to make sure that you do follow it. It's basically you're going in a spiral pattern, in, out. And when you're taking it off, logically, you go in a spiral pattern, but out, perimeter, inward. And just to be clear, I'm not going in the exact reverse order that the tightening sequence is specified, so, don't worry about trying to follow along what I'm doing here. Because removing the bolts, it really doesn't matter. And the bolts are going to be all the same length, so you don't have to worry about, different bolts in different locations in terms of their length. They're all the same. All right. With respect to the internals, okay, pretty much every 6L8090 or 6L family unit that you come across that you're going to work on is going to need significant reworking and overhauling. I mean, it is just what it is. No way of getting around it. If you do find one that's in really good shape, I mean, I don't know, maybe mark your calendar, because it's extraordinarily rare. Anytime I rebuild one of these, the pricing, the pricing or cost of overhauling the pump completely is included in that, in that estimate. It's not like, well, if you have pump damage, then, we'll deal with it. You're guaranteed to have pump damage. If you don't, it's like a minor miracle. So, I mean, you can inspect the working surfaces if you want, but I would say there's almost no point in doing it, because you're going to have to machine the pump anyway. And these pumps, at least as far as on the body, they have to be machined on a vertical mill to make sure that you can not only resurface the deck, but you have to cut the pocket so that you maintain your clearance. And you want to be a max of 2/1000 clearance on rotor and slide. The other thing is these vanes, don't ever reuse them. Purchase new vanes. And when you go back to overhaul the unit, you want to have a checking tool so that when everything's put back together, maybe you have your converter present, maybe you don't, but I like to use the checking tool. You want to insert that checking tool, which is basically a converter journal tool, and rotate it to make sure that the rotor will turn inside the pump assembly. Because if it doesn't, and you've already verified clearance is correct and everything's been machined properly, more than likely it's the vanes themselves that are bad. Aftermarket vanes, every once in a while, will produce a out of spec set of vanes, and it'll prevent movement because there's interference. In other words, they're too tall. So vane goes in like this. Maybe it's like 1/1000th or 1/1500th, or 1,500 too tall. Okay, rotor is selective. So in other words, there's different thicknesses. I'll put the thicknesses on the screen. And you want to make sure that when you when you go and bring your castings to the machinist, that you also bring your rotor and slide, so that he has those. Whichever ones you're going to be using, he has those for reference and can set the clearance using them. Okay, pump body bushing obviously has to be replaced. All right, you want to inspect the slide, make sure that in here, as well as out here on the perimeter, on all these surfaces, especially right here, is not worn. For my part, I mean, that's assuming you're going to reuse the slide. I wouldn't bother, to be honest. I would just replace it. The slide does have a support, and then there's a support O-ring underneath. And this support O-ring is like a Teflon material. And then you have your support O-ring. Hey, again, these come in the kit. They're to be replaced, along with the little slide spring that you see here, or a little pivot Teflon piece. There's a square one, and then there's this cylindrical one. Then you have your pivot pin and spring assembly here. So this goes like, right here on the slide. That can be reused unless it's damaged or something. Your pump O-ring. It goes in the trash. Alright, so again, you're not really going to inspect any of this, you're just going to machine it. Make sure that whoever you use is experienced and versed with working on 6L family of transmissions in terms of pumps, etc. And then, as I mentioned, just don't forget this snap ring. I'm not going to take it out for now. I'm just going to throw this in the back so it can get jet washed. As far as the seal is concerned, there is a tool you can use. It slides up right under here. I believe I feature it in my 6L80E tool video. And use that with a slide hammer, and you can pull the seal right out, and then you just use a seal driver to reinstall the new one. That's it. Let me get this out of the way and I'll be right back. Okay, so for your stator, you'll want to make sure that here in the bore there is no grooves cut into the sealing surface in there. So just give a very thorough inspection visually and with your finger. You also want to inspect the journal surface here. And you got your non-selective thrust washer, which again you're going to have to replace this with the Sonics or some aftermarket equivalent counterpart, because your end play is going to be larger than what is called for by GM, and I think 10 to 35 thousandths, somewhere in there, is the range that GM it kind of sets at the factory with these things. This one don't want to come off. It's being stubborn, not cooperating. There it goes. So I'm going to pull these bolts out now. So 8mm. Okay, I'm not going to do anything with the valve trains right now. That'll be in a separate video, but your converter clutch control valve and your converter limit valve must also be tested and inspected to make sure that they are not worn, because if they're worn, that it could contribute to converter clutch failure. I shouldn't say could, it will. And again, you want to know that, especially if the converter failed in your unit. We will also closely evaluate the pressure regulator valve. The balance side likes to wear heavily, and that'll cause a whole bunch of drivability issues, including slippage, or if it's stroked in the on the high side, the high line pressure. Real high line pressure has a tendency to shatter the lugs on the center support and the 2.6 clutch location. So it's somewhat analogous to the 4L80Es, TH400s, where high line pressure in those transmissions will destroy the case lugs where the intermediate clutch is. So that's why for real high performance, high RPM, where the line pressure is boosted, you use case savers to prevent that from happening. I'm not sure if there's an equivalent for the 6L80 or not, but I guess I'll have to look. But moral of the story here is that if your pressure regulator valve is worn, you want to replace it. You also really want to scrutinize these valve trains themselves and the bores, so that if you need to replace the pump cover, you can do so with a good used one. All right, I'll put this aside. To my knowledge, there was no changes to the any of those valves in the pump cover. The only changes that off the top of my head, that I can recall, are those that I already mentioned. Transgo makes a set of unbreakable pump rings for this, for these transmissions. It's a good idea to install them, especially if you're going to be doing something high performance. They're ductile iron rings, as opposed to the either cast powdered metal or whatever the hell the rings are made out of from the factory. And they will not break. Rotor failure is a lot of times attributable to pump ring failure. All right, here we have our 3.5R clutch drum. So there was a whole host of changes that took place in this drum, the drum itself, as well as some of the components therein. So early units prior to 2010 had a chronic failure rate of the 3.5R clutch. So in other words, slippage in third, fifth, and reverse, or eventual total loss of reverse. and or total loss of third and fifth neutral conditions, because the welds here at the base of the drum, they like to crack and the drum will leak. Apply pressure for the 3/5R clutch at those cracks. And what you want to do for all 6L80Es when you go to inspect them is you want to make sure that you test the drum. Not so much because you're just going to put it back in like that if it's good, but because you want to just definitively diagnose 3/5R burnup if you see it. Now, in 2010, they changed the welding procedure, and the welds are much more robust, so the failure rate as a result of this problem was significantly reduced. But you still want to check it just the same, and you could still reinforce the welds just the same if you would like. On the earlier units, it's mandatory. On these, it's kind of builder's choice. Point out something real quick. If I could zoom in. Okay, so there's some information here on the the inner surface of the base of the drum. It says 242-37182. That's the part number. And then it has a Julian date, the date of manufacture of this particular drum. It says 04511. That means it was manufactured on the 45th day of 2011. That becomes important if you're working on a transmission during a change year, so that you can definitively identify whether you have an early design or a late design relative to whatever change, or changes in question that you're looking to understand. Now, before I take that out, I actually want to test this drum and kind of show you what that procedure looks like. To do that, you're going to need some sort of drum checking or test tool. So you're going to use air to simulate fluid. I'm just lube up the little O-rings here, and then we'll lube up the inner surface of the sealing area on the drum. Okay, and then what you're going to do is just sit it in there, turn it right side up, and then reinstall your locking tab. This particular tool takes a 9/16 nut. There's a few different versions of this tool out there on the market. I like this one. When I was shopping for 6L80E tools, I think I remember seeing 3 different versions of this, and this one looked like it was the best made and easiest to use. Alright, so what we're going to do is put a little bit of fresh transmission fluid all around the weld area, and then we're going to introduce air into the 3/5R feed port. We'll also check the 1, 2, 3, 4. I mean, why not? Just to make sure it's applying, or if it's not, at least, okay, if we see burnt 1, 2, 3, 4 clutches and the piston itself isn't cracked, we know why. And that's the main thing with the 6L80s, or really 6L whatever, 6L45, 6L50, 6L80, 6L90. You really want to understand why a particular failure happened, why the transmission is sitting on your bench. And if you build these things regularly, I mean, you don't need me to tell you that. You probably know a lot more about them than I do. But if you're new to the units, then this is an absolutely critical part of the rebuilding process. I mean, it really starts with the teardown and inspection. I mean, that's true of all transmissions, but it's just really true of these. Especially true of these, I should say. All right, change camera angle. I gotta keep watch on the battery because this camera's batteries drain quick. I mean, I'm filming in 4K, so I get like 25-30 minutes and then it craps out on me. Okay, so we're gonna introduce air first into 3/5R. Okay, you can hear it apply. You got a little bleed hole right here by my, by my finger, so that's not indicative of a weld, fracture or failure. Let me just pound on this a little bit, make sure it's absolutely seated. Yep. So as you can see, we got a little bit of leakage coming out right here, right where my finger is. It's not huge, but it's there. So with these drums, all you simply need to do is have your machinist or yourself reinforce the welds all the way around, and that'll fix the issue. Okay, nasty fluid dirtying up my tool. Okay, you will do the same check process, same air check on the drum upon reassembly to make sure that it's good to go. You've installed all the lip seals and O-rings that are in this drum that you'll see in a little bit. Make sure that you didn't cut them on the way in. And I'll talk about some symptoms that you'll experience behind the wheel if you do. All right, let's inspect the clutch packs. So all the clutches in the front of the transmission, in other words forward of the center support, are such that they have selective snap rings. Okay, I'll flash the clutch clearances on the screen so that you know what they are, and I will also flash all of the different thicknesses along with a means to identify each particular snap ring based on the color code that I'll show you in a second, so that you know what you need to do to get your clutch clearance dialed into the range that the factory calls for. This is a clutch-to-clutch transmission, and having your clutch clearance be within the ranges as called for is absolutely critical to the functioning of the unit. If you are outside those ranges, you will have all kind of drivability symptoms and problems. Everything from bind-ups to tie-ups to flares. They can happen, intermittently. They can happen only on, first, shift cycle and your first drive cycle, and then, the computer will adapt and make them go away, but then they'll reappear. So where you normally would see something like this is after a rebuild, because the builder did not have the correct clutch clearances, when you went back with it. So here is your 3/5R ply ring. Inspected, make sure it's not damaged or broken. This is going to be your cushion plate. The cushion plates for the 3/5R and the 1234 were changed in mid-2007. They both have 18 teeth all the way around. In the previous design, the 3/5Rs had 12 teeth, and the 1234s had 9 teeth. So we'll look at that snap ring in a second. So inspect your pressure plate, make sure it's not burnt, warped, or otherwise, blue, discolored, showing that it could potentially be warped. Your frictions, your steels. These look in decent shape for this clutch. Okay, in the later units, I don't see these destroyed or damaged or burnt up too often. It's really the 456 clutch that kind of takes the cake there when it comes to being smoked. Okay, so you got 4 frictions, 4 steels. Alright, so let's talk about the snap ring. So right here, if you can see it, if this camera will focus, alright, right there, you'll see a little color indicator. That color will correspond to a range of thickness of this snap ring. So this thing looks like it's 105 thousandths thick. Alright, now if you've got to replace the drum for some reason, it's possible that you're going to need a different snap ring. So you'll need to know that information. You need to know that they're selectable so that you know to look for one. Okay, the other thing I need to point out, whenever I find it, is there's a lug that has no snap ring groove, and it's right here. Okay, in some drums it's you know, just the lug is contiguous, it's uninterrupted. It's true of the earlier ones. In this case, it's just they got a groove there, but it's, you know, below. Whatever you do, make sure that the ends of the snap ring kind of, you know, on either side of this one lug. And the 1, 2, 3, 4 clutch has the same type of deal. If not, the snap ring will pop out and you'll lose reverse, third and fifth gear. So, and that's obviously no good. All right, 1, 2, 3, 4. It's going to be the same situation. And I can get the snap ring out to show you. Okay, you want to look for the identifying mark, and we see it here. So this snap ring is, and I'm about to lose my battery. It looks like it's also 108 thousandths. Okay, got to change out the battery and then we'll continue. All right, battery change, fresh battery in. So take a look at your 1, 2, 3, 4 pressure plate, and it's going to be true of your steels. Notice how they're all aligned. All right, they have to be that way when you go back with it, otherwise you're never going to get that 3/5R ply ring back in there. All right, same deal with the cushion plate, 18 teeth. That was changed from 9 teeth. And then you got your requisite 5 frictions, 5 steels. So again, the piston, the design of the piston for the 1, 2, 3, 4 changed a couple of times. I believe there was a change in 2008 and then another one in 2010, and there may have been more, but I'm almost positive that those 2 years saw some changes. They changed the piston and they changed the design of the piston housing. So, you know, once we take apart the rest of the drum, we'll go over those changes in detail. But suffice to say, here's my advice when dealing with this particular clutch and piston. I would just simply install the Sonex billet aluminum piston. That'll fit any year of 6L80, and it's stronger than any of the GM pistons. So, you know, it's up to you. But if you want to just really de-risk this part of the transmission where, you know, there's been numerous pattern failures over the years, I would simply just install the Sonex piston and be done with it. But you know, some builders, they will keep the piston if it's a late design and if there's no signs that it's, you know, damaged. Okay, this clutch looks in good shape. You know, it and the 3/5R clutch would have worked. Okay, so to take this drum apart, you're going to have 2 snap rings. You got the 1, 2, 3, 4 snap ring, which was updated in 2007. The snap ring liked to pop out in the very early units, and that obviously would cause no movement in forward gear, no drive, no nothing. And then the 3/5R snap ring, which is below it, was updated in 2011. And that snap ring also liked to pop out in earlier models. And that snap ring, when it popped out, would cut the O-ring that's underneath it here on the stator, you know, or the ceiling ring area, what have you, you know, on the other side of it, obviously. And when that O-ring is cut, you would basically have uninterrupted fluid flow of apply fluid flowing to the 1, 2, 3, 4 clutch and 3/5R clutch at all times. So in other words, when you go to put the vehicle in reverse, you'll have a bind up because fluid that would normally be prevented from hitting the 1, 2, 3, 4 piston would flow unimpeded to it and apply that clutch at the same time that the 3/5R clutch was being applied in combination with the low reverse to give the vehicle reverse. And then you would have a tie up and it would be bad. So there are lip seal protector tools that you can use to
install a snap ring and it'll protect the O-ring so that you don't have that issue. But suffice to say, that snap ring popping out is is primarily why they decided to update that design change, because obviously the result is, requires a unit to come out and be dealt with. So anyway, I'm going to go to the press. I'll take the camera over there so you can see. You will not be able to remove these snap rings with just a regular foot press or bench vice mounted unit. At least not any of the ones that are available commercially. You can fab one up because it's just too big, too wide, and there's too much tension. These Belleville style return springs are just simply too stiff per se. Unless you have a really, really big foot press. So most of the foot presses, at least that are available that I've seen, including my own, are not sufficient, beefy enough, wide enough, whatever, to deal with this. So we've got to use the shop press. All right, enough babbling. Let's go over there now. All right, so the tool I'm using here is Kenmore DT47867. Again, I cover this in the tool video. This is used in lieu of some of the specialized ring compressor tools that are available from Kenmore. You can go the route of the individual ones. Obviously they're designed specifically for the transmission, but I find that this one is a good substitute and works well. So there's the snap ring ends right there. Tighten this up just a little bit. I just want enough room to get the snap ring out of the groove and off the drum. So if you have an older model that is previous to the change, either in 2007 for this one and 2011 for the other one, there is a snap ring kit that you can buy that will update you. Now, the earlier snap ring, as far as the 35R version is concerned, is actually what you want to use. That'll work for both. You do not want to use a late design snap ring in an early drum. It won't work. It'll pop out. All right, let's see if I can get this balance piston. So we have our balance piston, and then we have our Belleville spring. Note that the conical side is facing up toward the balance piston or piston dam, and then the side of the dam with these three little tabs faces up. All right, sometimes I can get the piston out here on the press with these soft-jawed pliers. You don't want to use anything that's, potentially damage it, but other times I'll just put air in it and then it'll pop right out. All right, I have to go back to the bench for this. All right, let's pop it out. I mean, if nothing else, you have a really good seal here between the sealing rings, so that tells me they're very healthy. And we saw the 1, 2, 3, 4 clutch was, largely undamaged. So that's the piston. Let's clean it up a bit. And you can see the manufacturing date right here, along with the part number. This is the date and time stamp it was produced, so you know exactly what vintage of piston you're you're working with here. All right, so here's that O-ring I was mentioning. This O-ring segregates the 1, 2, 3, 4 clutch from the 3, 5R clutch, so that when you throw the thing in reverse, you do not have a situation where you're bound up. And it's not really an O-ring, it's a D-ring. I mean, I call it an O-ring, but it's really a D-ring. Okay, 3, 5R. So I should mention with the piston, the housing also changed. So you have to make sure that if you're replacing the piston and you want to stick with the factory piston, you match piston and housing. So that's why in large part all that date and timestamp information is cast, or I should say laser imprinted onto the piston. All right, let's go back to the bench so we can take out this other snap ring. So again, this snap ring changed in 2011. The part number that I flashed across the screen will install in any gear drum. But what the change involved was deepening the snap ring groove down here so that the snap ring wouldn't pop out. Because like I said, when it pops out, it likes to take out that D-ring seal and cause the bind up in reverse. Oops, you know what? Got the wrong pliers. Alright, so I'll have to use this style snap ring pliers to just get it loose, and then I'll finish it off with the other style. And that's assuming I can even get on it. And that's more user error than anything else. The snap ring is physically larger in diameter relative to the 1, 2, 3, 4 ring, so it's not like you're going to be at risk of potentially misidentifying them. This one is definitely the trickier of the two, as you can see. It really will fight you. It'll fight you coming out, and it'll fight you going back in. Is what it is. Okay. If you haven't figured it out already, you definitely want to remove that 1, 2, 3, 4 D-ring before you take this off. Now, there is a special tool. If I didn't mention it already, I think I did. But there's a special tool. It's kind of like a seal protector tool that goes in over the journal here, and allows you to install snap rings. Let's see if this will come off. It probably won't. Okay, I'll use the air tool to force it out. Alright, so here's the two snap rings. This is your 3.5R, this is your 1, 2, 3, 4. Obviously there's a difference, clear size difference between them, so you not mix them up. So the kit that I've been referring to comes with these two snap rings along with the 456 I-loop style snap ring that holds that return assembly in place. It's my recommendation that you replace those snap rings on overhaul with new ones in the kit. Now, like I said, put the GM part number, flash it on the screen, or put it in the description so you have it. Probably going to be a whole bunch of information in the description, you know, for this transmission. Okay, drum's empty except for the 3/5R O-ring here. So I guess it's more accurate to say it's free of all pistons. Okay, so this goes in the groove right down here where my, you know, where my index finger is. And then you have additional O-ring here. See it? On the very base of the journal, or I should say stator. So there's your 3 O-rings. They're not terribly difficult to tell apart. You know, this is the one that likes to get severed when that 3/5R ring pops out. This is the middle one, and then this is the bottom one. So very easy to tell apart, no big deal. Alright, so we have the 3/5R piston and the 3/5R piston housing. There is 3 additional sealing rings on the piston, and the housing has one as well. And they sometimes will be in there. So here is your Belleville spring. Again, the conical side faces up, so it goes in like this on assembly. And then you have your 3 sealing rings here. They're all rubber. So if you're not familiar with these transmissions, my advice would be to actually wash this with all the sealing rings in place. This way there's no chance you can mess them up. This one is ever so slightly larger than this one, but you know, if you're not paying real super close attention, then there is the possibility that you can install one, you know, in the wrong location. Now when you go to try to do that, it should be obvious to you that it's not correct. It'll be too big and or too small. But, you know, again, just as an added safety precaution to de-risk the build process, you know, you can leave them on there. So there's quite a lot of materials. So there's quite a lot of components in this drum, obviously. Okay, you're going to replace this bushing. It comes in the bushing kit. All bushings must be replaced. You're also going to replace this needle bearing assembly. Just take a screwdriver and pound this out. And then there's a special tool to reinstall it, a bushing driver that is designed to protect the sealing surface here on the perimeter. This green section here is a lip seal, so just be careful that you don't cut it on the way back in. All right, let's move to the 456 housing / front planet assembly. So this sealing ring here is what you want to check. Okay, just, you know, eyeball it, visually inspect it, compare it to the other sealing rings. If this is flattened or cut, then that would by itself explain converter failure, converter clutch failure, because that's an important part of the entire apply circuit, you know, sealing I guess, sealing chain or whatever, however you want to say it. I don't know. I'm kind of at a loss for words, fumbling around, but I think you get the point. The other area you want to make sure is you check this journal. So I'm going to get this apart, and then we'll bring back the stator pump cover assembly, and we'll show you how to inspect that bushing to see if that should remain on the list of suspects to investigate for the converter failure. Because if that input shaft O-ring on the very end of it is good, in other words, it's not flattened or hardened or anything like that, if the sealing ring on the top of the input shaft here is good, the bushing is good, otherwise not excessively worn, then your next step is to test and investigate the converter regulator valve in the lower valve body, the converter limit valve, and converter clutch control valve in the pump cover. And that's why we did not want to disassemble those valve trains just yet. And I'll do that in a separate video, as I mentioned, that will take you through that inspection process. So this is your front planet or input planet. Notice the orientation, notice these splines. The 3.5R drum will have a set of splines that will spline into the front planet. If for whatever reason you put that planet in upside down, then you will not have any movement in any gear whatsoever, because you will have severed or broken the link between the input side of the transmission, your input shaft, and the output half of the transmission, which starts at this junction right here. Okay, so let's remove the planet so we can inspect it along with the sun gear. And then you'll see a bearing and a thrust washer that goes on the bottom side of the planet. All right, every once in a while this will see, you'll see it burnt or broken. Obviously just replace it, but you'll want to investigate as to why that is. It's not common. And then your bearing. Notice here the kind of top hat flanges, they will face up. Alright, so here's your sun gear. The sun gear you can put in any old way, doesn't matter, it's not direction specific. Just check the teeth, check the splines. If the splines are excessively worn, you want to replace, because this is where the pump, the stator splines will mate or mesh with these splines. So just check that, and obviously check the splines on the pump too, the stator, if I didn't mention that already. And then for planets, you're not going to do anything different with this planet than you would all your other planets. Check these splines, make sure they're in good shape. Check the housing itself, make sure there's no signs of cracking, any kind of damage, chipping, heat bluing, if this thing massively overheated, or the planet suffered a lubrication failure or lack of lubrication, you'll see that. Check the pinions here, make sure there's no bluing on any of those. Again, same deal, most of the time it's a lubrication or lack thereof. And then go ahead and grab your pinion gears. Go back and forth. What I'll do is I'll actually put a little downward pressure on it, because if you try to check them in the middle, then you'll be checking them up and down, and you might think it's wobbling, but it's not. So just check them all. And then you can start checking them up and down. There is a spec. I'll locate it and stick it, in the notes, or on the screen. But if, there's some problem with the planet, it's got side play or it's got too much vertical play, you can rebuild these. If you don't want to do it or not sure how, you can take it to your machinist. And typically a machinist that works on transmissions and transmission parts, one of the things that they'll do frequently is rebuild planetary carrier assemblies. All right, here is the journal in question. We'll check that in a second. But first, let's have a look at that 456 clutch. And it is smoked. Smoked. I don't have my other pick. Okay, this snap ring is also selective. So, as you can see, we have a absolutely destroyed clutch pack here. I mean, it is absolutely destroyed. So 6 frictions, 6 steels, pressure plate and wave plate. So in this case, I would replace everything in here. I mean, none of this would be reused. I would install the Sonex Apply Piston Kit. That will allow you to squeeze in an extra friction and steel of, standard thickness into this clutch pack. It's highly recommended. It's a great little upgrade to strengthen, the durability of this thing. All right, these are also marked. There is one that is not marked, one snap ring with a specific range of thickness that you will not see any kind of color markings on it. This particular one looks like it's just shy of 100 thousandths. So you want to keep the snap ring for reference, but just be prepared to replace it as well. Like if the clutch comes out looking like this. Same with this, I would not reuse this wave plate. I would just throw all this stuff into the scrap bin and let the scrap man deal with it. All right, let me go get that stator. Easier if I did it this way. So I'm going to take these sealing rings off. There's a special expander and sizer tool that you'll need to reinstall the new ones. That's available either from Kentmore. There's a DT or J tool code for it. Adaptacase and others make make alternatives that do the exact same thing. Again, my tool video, I think I show mine, and it's not a Kentmore version. Alright, so what I'm doing here is I'm just rocking this thing back and forth to the extent I can. And I'm looking for side play. It's got a little bit, but not a lot. The next step would be to take a micrometer, and you're probably going to have to use like a little caliper because it's going to be tough to get a micrometer in there. I mean, maybe you can do it, but however you want to do it. Check the journal, almost like you're checking a journal on a crank, main or rod journal. Check it down here, check it up here, and then use an inside micrometer to check this. If the difference is more than 0.02 of an inch, then you got kind of a prima facie case for excessive bushing wear here to be a material contributor to converter failure. All right, this assembly does not come apart other than these pistons, so we'll go to the foot press and we'll take these out. Like I said, this is the only clutch pack where I can use the foot press to remove snap ring for the return piston and balance piston assemblies. I'm going to drag the foot press over here. I'm going to move the camera. And apologize in advance if this video feels like it's dragging. Like when I'm going through this, one of these, just in a normal course of business, It doesn't take anywhere near this long. But when you film, especially if you're filming, auto repair type videos, it tends to add about anywhere from 50% to 100% additional time to complete whatever job you're filming than if you were just not filming, just simply going through it in, more or less a workmanlike manner. Don't get me wrong, I love filming. I want to continue to add content, but if you endeavor to kind of do your own channel or start your own channel, just be aware of that and know that going into it. All right, so this is kind of an eye loop snap ring. So it's going to take pretty much all my weight to compress this thing down to where I can get at that little snap ring and pull it off of there. And I can't remember if these freaking, wrong ones. As you can see, it's just, I have barely enough compression to work this snap ring off. And it does not want to cooperate, of course, because it knows I'm filming. If I wasn't filming this thing would practically remove itself. So this comes in that snap ring kit I was referring to earlier. You'll want to replace it. All right, let me get the press out of the way and then we'll remove those pistons. All right, so you got a balance piston or dam, and you got your Belleville plate, and then your applied pistons. So all three of these would be replaced in this transmission because of the amount of heat that this clutch sustained. If they're otherwise in good shape, then you can reuse the balance, you can reuse the return spring. You always replace your molded pistons. Never ever reuse molded pistons in any transmission, not just this one. All right, so these can go in the trash. This is gonna go in the scrap bin. And same with this. Oh, my aim is off today. As far as the drum itself, you want to check. Just make doubly sure after you clean it that there's no cracking, no warping, nothing that would otherwise lead you to believe that the drum itself is structurally compromised. Check your ring gear teeth, make sure they're okay. This is captured, it doesn't come out or anything. So if it does come out, then obviously you replace the whole thing. I just want to clean that up a little bit. So again, this is another case of, use your judgment. If it were me, given, like I said, what this looks like and the amount of overheating that went on, I would be inclined to replace the whole thing. Just again, being conservative, being, MECE, mutually exclusive, collectively exhaustive, meaning you leave no stone unturned and you satisfactorily address all areas of uncertainty to reduce the risk of your build coming back. I would have the customer replace this drum, or that drum, this drum, that drum, the other drum. So the 3.5R drum in this case is fine. It just needs the welds reinforced, but other than that, it's good to go. It'll take a snap ring kit, an overhaul kit, new set of frictions, new set of steels, and a Sonex billet aluminum piston for the 1, 2, 3, 4. All right, let's talk about these hubs. So you got your 4, 5, 6 hub. That's this thing. This is your 1, 2, 3, 4 clutch hub, and this is your 3.5R clutch hub. Okay, of the 3 of these, you're gonna have problems with the 4, 5, 6 hub. Okay, so here's the front side bearing. Note the little tangs. They face you. They face up when you're dropping it, you know, down into the transmission on reassembly. So this this hub contains a damper, and that damper is designed to, you know, common sense here. It's designed to dampen vibrations that are generated, and this is, I'm going to use GM's verbiage here, to dampen vibrations generated by engine pulses. So translate that into English, simply means that as the engine is doing its thing, you know, during the course of operation, certain vibrations will be generated and kind of pass through the transmission. What this does is it dampens those vibrations so that they don't build as, you know, they pass from the front of the transmission to the rear of the transmission. Now, prior units, families of transmissions, you know, everything from power glides up to, you know, 4L80s or whatever, did not have a dampering system. These did. So engineers obviously saw it fit to install something like this to prevent drivability symptoms, discomfort, harsh shifting, you know, and other problems that otherwise might occur. All right, so take your cover plate off. And then your damper is in here. Okay, this side faces down or rearward. Actually, I should say more accurately, it faces frontward, but it faces down when you have the hub facing up. This is a bearing race and a bearing all in one. It's captured, it doesn't come off. So in this case, we would be replacing this entire hub with a good used unit. If it was a factory build, if it was an aftermarket, if it was a high performance, heavy duty type use case, we would install one of the billet aftermarket options that are available. I like the Sonex one because it'll allow you to run the factory damper, but it's otherwise has a billet steel 456 intermediate shaft, and it is heavily reinforced compared to the stock piece. If this breaks in half, which sometimes happens, you know, you're not going to have 4th, 5th, or 6th gear. So again, we replaced this because that is kind of a risk given all the heat damage it sustained. It would go to the scrapyard. Okay, your next hubs are your 1, 2, 3, 4 hub. You have your axial bearing in here, just like this. And then this is the other side of it. Okay, there's no bushings in this hub. This is your 3.5R. There's a bushing here, and there is a bushing here. They both need to be replaced. And here you have your bearing, integral bearing, and bearing race, so it's like a dual stack bearing. And then you have your other bearing that faces the 1, 2, 3, 4 hub. So it's like this, and then this faces the center support. All right, speaking of the center support, let's work on that next. Now, unlike the other 3 clutch packs we looked at, there's no selectives in either the 2.6 clutch, which is this, or the 3.5R clutch. Both of these clutches are set at the factory to be 50 thousandths clearance, or to have 50 thousandths clearance. So if you do not have that when you go back with it, then you'll need to figure out why that might be. Could be anything from misinstalled, return spring or applied piston, or something, maybe debris caught up in the clutch pack itself and you didn't see it. It could be the wave plate. The wave plate could be somehow, more bent than it is. So 5 frictions, 5 steels, and they look in good shape. Okay, this underwent a design change as well. Both this and the low reverse frictions, the friction elements. What they did is they changed the pattern. This used to have an X pattern in friction. It's now radial. And then the low reverse, they also changed from I think. Well, I don't want to say. I don't really know. But it transitioned to an X pattern. So let's take a look at those. There was a kind of a pattern of complaints of shuddering on, when in reverse, and the cause was traced to the design of the frictions, and that's why they changed them. And in the case of the 2.6, there was rattling noise. All right, so these are radial as well. They changed from an X to a radial, and that occurred, I want to say, in early 2000. I want to say either 2007 or early 2008, but I'll have to research and then I'll annotate in the event that's wrong. So anyway, 5 frictions, 5 steels on a wave plate. Again, 50 thousandths clearance, set from the factory and not adjustable. All right, so we're gonna have to go to the press so that we can remove this snap ring right here. All right, and I'll point this out again when we get over there, but there is a set of splines here on this side of, on the side of the drum, here on the quote-unquote stator portion, and those splines mesh with the inner splines for the inner race of the sprag assembly here. And there is one set of splines that's actually missing. In other words, it's what's called a blind spline. Blind spline. English is like my second language today. You want to make sure that when you go back with it, the ends of the ring kind of bracket that blind spline. All right, you got a bushing here that needs replacement, and you got a bushing here that also needs replacement. Okay, let's go ahead and go to the press, and we'll remove remove this assembly. And as far as sprag rotation, it's going to be freewheel counterclockwise, lock clockwise. Okay, and as mentioned, this sprag was changed. Early units in 2006 and early 2007, the sprag had only 30 elements, and those sprags were known for failing, for slipping when you're taking off in in drive, or they would just straight up roll over and fail altogether, and you'd lose all movement. You'd have a neutral condition. So they upgraded to a 38 element design, and complaints largely ceased that were driven by sprag failures. So if your sprag does roll over, if it fails, if it's freewheeling in both directions when you take one apart, you need to replace the entire sprag assembly, not just the sprag element itself. And that's true of all transmissions. All right, let's go back to the press. Yeah, you don't have to press a ton. You just have to collapse it enough so that the snap ring is, free in its groove. All right, go back to the bench and we'll break it all down. All right, so if I didn't mention it before, this snap ring also has to be replaced on overhaul. It is a risk of breaking if you go back with it. So it's a different part number. It's not included in the kit that I was alluding to earlier for the 3.5R drum and 4.56 drum. So I'll flash the part number on the screen so you can see it. And then you can grab your sprag assembly. Okay, just check it. There's a snap ring here that you will need to take loose. And then you have your kind of top plate. And then you just force up the inner race, or force it down, if you will. And then you have your Sprag clutch itself. All right. I mean, you can inspect it just to, determine if any of the drivability symptoms as reported can be attributed to the Sprag failing, but chances are you're not going to see wear unless, it's already rolled over. Beyond that, you're not going to reinstall it anyway. It's going to be replaced on overhaul. And that's the same with pretty much any one-way clutch in transmissions. All right, let's see if I dinged up the race. Nope, looks okay. All right, so check your inner race. You should have a mirrory smooth surface like this. Okay, this looks to be in good shape. Notice your blind spline here. Okay, that aligns with the corresponding blind spline on the drum. Okay, for your outer race, much like any other outer race, you want to check it for excessive wear. If the whole surface is really, really shiny, and or you notice that it's, not perfectly flat, or it's got scoring, then you want to replace it. Otherwise, you could take some 400 grit sandpaper and just kind of go all the way around, and that will reintroduce the crosshatch pattern so that your new Sprag elements will have a nice surface to bite into. Okay, here is your Belleville return spring. Again, conical side faces up. And then you have your O-ring. And again, there is I believe there's a special tool that you can purchase to, fit over the splines to install the O-ring to help prevent, it from getting torn by the splines. I mean, do you need it? Not really. You just have to be real careful. This one's in good shape. So bushing there. We'll get to the 2.6 piston assembly in a second. So, low reverse piston is molded, and it is to be replaced with a new one. So when it comes to molded pistons, I always default to the OEM, the ones made by National Seal Company. There are aftermarket pistons available that are blue in color, and I believe, I think they're made by a company called ATI or something like that, and those are manufactured overseas. So if you look at the piston here, National is the company that makes them. And that's true of all the GM transmissions, and I believe all the Fords and Dodges as well. Okay, so to recap, we have our race elements. Check them, make sure they're good. If not, just replace. The snap ring for the Sprag assembly needs to be replaced regardless. The snap ring that holds the Sprag assembly itself together can be reused. As far as Belleville return springs, again, it's really up to you if you want to reuse them. General best practice, if you really, again, want to be mutually exclusive, collectively exhaustive in your rebuild, you replace all of them. Not everybody does that, and in my opinion, it's not super necessary unless, of course, there was a lot of overheating. Like if your 3.5R clutch is of the earlier variety and it came in smoked. I would suggest replacing the Belleville springs in that clutch. And that includes the 1, 2, 3, 4 spring also. All right, just check the aluminum lugs, check the snap ring area, make sure you have no excessive wear anywhere, nothing that would lead you to believe that the snap ring might fail. Check the sealing surfaces, again, for scoring. The transmission saw a lot of contamination, and you might have scoring down here, and that would obviously be real detrimental to the new piston. It might cut the sealing surface, so replace it if that's the case. So you have sealing surface here, here, and then here. Okay, check this area and the splines. Make sure they're not worn out. Make sure they're not damaged or gouged or whatever the case may be. If they are, again, replace the assembly, or replace the drum rather. All right. So your 2.6. Now, to get this thing back in, you're going to need one of two things. One of them is going to be very difficult to find. That's the special tool that's designed specifically to compress this Belleville style return spring. And this is the only one in the transmission, by the way, where the conical side faces down like a traditional unit. Now you might, if you're familiar with Ford and Dodge units, that's how their forward clutch Belleville plates and return springs are oriented. You can either use the special tool, and I'll flash the part number on the screen. And I did not talk about that tool in my tooling video because the other option is a lot cheaper, and that is to simply use the ring gear drum assembly. And I'll show that in a separate video, but just from a descriptor perspective, once you have the planet out of it, you put this on the bench, on the press, you stick the empty drum and output shaft over top, and it'll go all the way around here and give you enough space between the snap ring groove and the drum itself to where you could start seating the snap ring into the groove here, and then once you got maybe anywhere from 6 to 10 lugs seated, then you can go on the bench and finish the rest off with a hammer and a screwdriver and fully seat the snap ring all the way around, and it costs you nothing in terms of tooling. So but on this assembly, it just comes out. Okay, so again, make sure that this faces down, not up, conical side. There's your bonded piston. As you see, it has debris up in here, real fine granulated sand-like matter. From the converter. I mean, no matter, it's going to be replaced. But when you see stuff like that, you really need to critically inspect the sealing surface. So let's give it a wipe down. And I'm sorry, I kind of forget where the camera is actually pointing, so I'm moving the drum closer to me because that's kind of like, instinctual, right? I know what you're saying. Wouldn't it make sense just to move the camera angle closer? Well, I guess. All right. All right, we got it clean enough. We can do a decent inspection. Okay, just check all the way around. Make absolutely sure there's no scoring, no gouging. Nothing present to indicate that the new seal will be cut once the transmission goes back in the vehicle and starts working again. My advice, if you're in this situation, is jet wash this first, get it completely clean, and then do the inspection, and from there make a final decision if whether or not you need to replace it. This drum appears to be okay. I don't see anything, just again, looking at it with you, that would lead me to believe that I'd want to replace it. But like I said, I'm going to stick it in the jet wash, and from there we'll determine if in fact it is good to go or if we need to get a new one. So things like this, you see this, what appears to be a fracture. In fact, I think it is fractured. Take it off camera just for a second. Put it back. Zoom in. Here and here. I don't see anything on the outside lug, so whatever it is, it's not through and through. And I don't see anything coming up to the top. So again, this is a perfect example of why you want this thing fully clean before you make a final decision. So I'll have to pay real close attention to that when we pull it out of the jet wash. Okay, ring gear / planetary rear gear train, output shaft, parking pole, or excuse me, parking gear, and everything else. So, in 2012, the design of the ring gear was changed in this. They refer to it as a uni-gear. And they refer to it as such because previous designs had 2 separate ring gears for each of the planetary's, upper and lower, planetary gears. So we have our case output bearing, and then we have our center support to sun gear thrust bearing. Just want to make sure it doesn't fall over. So we have a needle bearing assembly here. This comes out. You replace this on overhaul. And then the snap ring here, you remove this to remove the Ravenel style planetary carrier assembly out of the ring gear housing. Come in like this with the screwdriver. You want to first go, I guess, perpendicular, and then slowly turn horizontal to pry it out of the groove. Alright, so since this is a 2011, it's going to have separate ring gears. Go wandering away. Okay, so just mesh it. So like this. And that's how the upper ring gear comes off. And then you have your bearing. That bearing goes here like this. This is going to be your planetary base plate to ring gear thrust. And of course it wants to now stick to the base plate. So, check your ring gear teeth. Make sure that there's no damage to any of these teeth. Make sure that there's no damage to the lugs here of any kind or description that would lead you to believe you would need to replace it. This appears fine. Alright, to get this other snap ring out, what I'm going to do is I'm going to wedge a small screwdriver in there and then pry it out with the other screwdriver. So you have a spacer here, and this spacer allows you to get like a pick or a small screwdriver. So just stick it in there, and then just come in like this. And then just slowly work it out. Okay, this, as you can see, the diameter of snap ring is fairly wide relative to inner diameter of the drum. Okay, this snap ring and the other one are exactly the same. Okay, there's no difference between them, so don't worry about mixing them up. Okay, same deal. Check everything over. I mean, I don't see anything obviously wrong with either of these ring gears or the spacer. As far as the drum itself, just check it. You have a bushing here that needs to come out for replacement. And then way down there, you'll notice is where your threads are for your lifting tool. So again, in my tooling video, I show kind of an improvised method you can use that's a hell of a lot cheaper than purchasing, either the Ken Moore dealership specific tool or any of the aftermarket counterparts. So as I was explaining earlier, what you would do is for the 2.6 to compress it on the press. Let's put our piston back in. You got your return spring, and then you would just simply take this to the press, stick it in there, and then you would have your snap ring. You would just spline it in. There's enough space to get it in all the way around, like that. And then you would take a thin screwdriver, once it's all the way in there, and start working it into the groove after you've pressed, introduced downward press force on this drum assembly. And you only need to get like really 5, 6, 7 lugs, 5, 6 lugs with the snap ring, and that's sufficient. And the rest of the way, you can just put it back on the bench and use a hammer to, firmly tap in the snap ring all the way the rest, into the rest of the lugs. Pretty simple. All right, plant it. All right, before we can inspect the planetary carrier and sun gear assembly, first thing we need to do is remove this needle bearing assembly. So a couple ways to do it. You can either use J23129, just comes up under here, and it'll, with a slide hammer, you can just wrap it out. Or if you don't want to acquire that tool, you don't have it, you have a flat chisel like this, it'll accomplish the same thing. You just got to be careful when you go about it. So just put the chisel here and come up underneath of it. And then again, make sure that you are firmly seated on the bearing and not the housing itself. And then just tap it out. It's going to be a little tricky because you got to apply a little bit of downward pressure on it to seat it fully, and then give it a smack or two. Again, this is the low budget way of doing it. And you also want to be very careful not to potentially damage the sun gear, the teeth on the sun gear with the chisel. It's going to take you a while to get it protruded out of the bore enough to where you can collapse it in. Okay. This bearing is going to be replaced when you go to overhaul the unit, so you don't have to worry about damaging it. Again, it comes out eventually. So it's got the part number there. And to my knowledge, there was no change to that bearing. So here's your top sun gear. Your intermediate bearing. Notice the orientation. And your bottom sun gear. Okay, notice the difference. And then way down below, you have a captured bearing. And you want to inspect that and make sure it, you know, feels nice and smooth. I mean, it should still be laden with fluid, so it shouldn't feel like there's a bunch of sand or, you know, other matter in it. So this is a Ravino style planetary carrier assembly. These are rebuildable. So you're going to go through the same progression of checks that you would with any other planetary carrier. First, we'll check the base plate. Wipe it down, and here we're checking for anything unusual, any cracking, any scoring. You want to check these splines, make sure they're okay, make sure they're not worn. Alright, just wipe it down, get it as clean as you can, and then just go through and, to the extent you can, check every single one of these pinions. Look for any excessive wear on the either face of the teeth. See where it contacts the sun gear. You want to see if there's any chipping, any cracking along in there. Okay. Check the top one too, and then just keep going round, performing basically the same procedure. All right. So you got 1, 2, 3 sets. Then check vertical play. You could do this however you want. I'm just doing it kind of in, you know, sequential order. And there is a spec for these as well as far as the vertical play that you want to manage to. Again, if rebuilding the bearing, or excuse me, rebuilding the planet is not something that you want to do or you can do, any transmission machinist specialist should be able to do it for you. All right, so check your lower sun gear or your rearwardmost sun gear. Okay, and these little notches you see here, that's, you know, they're also in the planetary gears. That's normal. Check your splines. Okay, make sure that you have this orientated correctly. This flat side faces down, and then this side here, where the splines kind of stop halfway up, or, you know, I guess that's 3/4 way up technically. This bearing goes like so, and then you have your top sun gear. All right, check your housing. Make sure the housing itself, there's no damage, no cracking, no signs of heat, you know, heat warpage. Check the pinions down here. Might be easy as well if you just grab them like this. Okay. You really want to go through these planets, spending a fair amount of time making sure that they're in good shape and that it's okay to reuse. They are expensive, they're not cheap. If the planet is bad, you're paying probably around $300-400, maybe more, for like a good used one. So if you build a lot of 6L80s, and to my knowledge the planetary carrier assembly itself never changed, I would advise to have at least a handful of these planets, you know, when you have the opportunity to take in a core for hard parts. Okay, that basically wraps up the subassembly inspection portion. I think I covered everything I wanted to cover in terms of parts changes and updates and, pattern failures. I mean, if there's something wrong with the rear gear train, you'll hear like a growling or whirling type noise, depending on how bad it is. And that also applies to the front planet. It'll be kind of unmistakable. You may also feel vibrations, although that's less common. Usually when these fail, you just simply start losing the ability to move. So you have delayed engagements into reverse, delayed engagements into forward, as pieces of teeth are chipping off and wedging themselves into the mesh between the ring gears, the planetary planetary gears and the sun gears, and that's kind of usually what happens. So is what it is. But anyway, to recap on the arrangement. Here's your rear sun gear. It's going to face down. Make sure this side with the no splines faces up. And then your bearing, like so. And then you're going to have your top side. And then obviously the new one would go back in. And your part numbers will face up on the new one.
Okay, we have everything back on the bench, cleaned up. So go ahead and summarize our findings with this teardown. Not too much in the way of damage other than what I usually see. 456 hub is smoked, that needs to be replaced. The drum itself, again, that's really a game time decision, but if you had to pin me down, I'd say I'd replace it. It should be replaced. But just because it's kind of heat soaked and stained doesn't necessarily mean it's compromised. But again, if you're not sure, just err on the side of caution and replace it, or have it replaced. So this transmission is going to need a whole bunch of parts, and that's true of all 6L80s and 90s. Going to be a complete cowl kit, 456 clean steels, 35R clean steels, a complete Torrington bearing kit, a complete bushing kit, 456 hub, cage needle bearings for the 35 and R drum, as well as the rear planet. Going to also purchase a snap ring kit, and that's for the 35R and 456, as well as a snap ring for the low sprag. Also need to purchase a new sprag element itself, 1234 billet piston from Sonics, a 456 piston kit from Sonics, the updated heavy duty parking rod that won't fail, a Sonic zip kit, and a Tecum solenoid filter screen for the valve body complex and the valves in the pump. Roll pins, gotta locate some pan bolts, and this is more or less optional, but I like to do it anyway, the unbreakable pump ring kit from Transgo. As far as machining is concerned, as I mentioned earlier and kind of talked over in some detail, we need to completely rework the pump. So that means resurfacing the pump cover and then resurfacing the deck of the body, as well as cutting the pocket so that we have our requisite 1.5 to 2 thou clearance between the rotor and slide, and in relationship to the deck surface. So and then we got to reinforce the welds on the 3.5 and reverse drum. So if you're not sure what a cowl kit is basically something that contains your filters, your friction modules, your bonded pistons, and they usually come with the pump bushings. So your 2 bushings for the stator and the 1 bushing for the body. And then of course all your seals and gaskets, O-rings, things of that nature, so consumables. Anyway, as far as upgrades for these things, you can do, in addition to the stuff I already mentioned, a billet Sonics 456 hub. I like the Sonics one because it allows you to run your factory damper. Some aftermarket hubs that are billet, I don't believe they allow that. So I've always used the Sonics, whenever I've installed a non-stock 456 hub. So you can also, if you're putting out a lot of power, and this is really only necessary if you're putting out like 700 plus, I would upgrade your rear Ravino planetary carrier to one with a billet drive plate. So this way that there's no risk of it, failing at the splines or warping of the billet cover. As far as torque converters, you want to go back with this thing with a converter that has a minimum of a 50,000th of an inch thick converter clutch. And I would say that's minimum. The factory converter clutch in there is 20 thousandths thick. That's just simply too thin and it doesn't last. The converters in my builder puts together for me contain a 70 thou thick converter clutch. Billet cover is also recommended, especially if you either A, going to be doing a lot of towing and hauling, B, if there's going to be high performance, in other words, racing, street strip, really aggressive driving and engines modified and upgraded, or if you're doing a lot of towing and hauling on a routine or very frequent basis. So maybe you have a boat, or maybe you're towing car trailers or something along those lines, horse trailers, whatever. I would recommend you go with a billet cover to prevent the stock cover from warping, because that is a common problem with these things. All right, that should kind of summarize everything. The only other suggestion I'll make is, if you're new to these transmissions, I would recommend try sourcing some different thicknesses of snap rings for the 1234 clutch, the 35R clutch, and the 456 clutch. You never know if you may need to make adjustments and get your clearance where you need it to be. All right, as always, thanks so much for watching. If you have any questions, comments, go ahead and leave them below. Otherwise, we'll see you on the next video.